Hello GATE aspirants, welcome to part 9 of GATE Atomic and Molecular Physics series. Question number 2. Which of the following represents 3p radial wave function of hydrogen atom? A0 is. 3p means N is 3 and P means L is 1. So this is R31. You can go through any standard book and you will see that this option B is correct one for 3p. R31 is proportional to R1 minus R upon 6 A0 e raised to minus R by 3 A0. Next question. Stern-Gerlach, we have to match group 1 with group 2. Stern-Gerlach experiment, so that gives you existence of electronic spin. Then Zeeman effect gives space quantization of angular momentum. Franck-Condon experiment, it is quantization of energy of electrons in atoms. And Davis and Germer experiment, wave nature of particles. So here option C is correct. Next question. The expression for the second overtone frequency in the vibrational absorption spectra of a diatomic molecule in terms of the harmonic frequency omega E and unharmonicity constant chi E is. Now we know EV is equal to V plus half h cut omega minus V plus half square h cut omega chi E. Now for second overtone, this transition will be from 0 to 3. So energy from 0 to 3, it will be E3 minus E0. So first put V is equal to 3 here. So 3 plus half is 7 by 2 h cut omega minus 7 by 2 square, that is 49 by 4 h cut omega chi E, minus it will be 0. So that is half h cut omega minus it will be plus, and half square is 1 by 4 h cut omega chi E. This comes out to be 7 by 2 minus 1 by 2 is 6 by 2, that is 3. So 3 h cut omega E. Here it is given that it is omega E. So this is omega E minus 12 h cut omega E xe. Now this is given that these all are omega E only, and this is h cut omega, and we have to find this omega here. So omega will be, if we take h cut common, this will be 3 omega E. We can take 3 omega E common here. This will be 1 minus, and this will be 4 chi E. So option D is correct here. Here also it is omega E. Next, match the physical effects and order of magnitude of their energy values given below, where alpha is E square upon 4 pi epsilon naught h cut C is fine structure constant, Me and Mp are electron and proton mass respectively. Then we have to check this. Now for lambda shift, it is proportional to alpha raised to 5. So lambda shift to alpha raised to 5 MEC square. Fine structure alpha raised to 4 MEC square. So fine structure 2. Then Bohr energy alpha square MC square, and hyperfine structure alpha raised to 4 Me square upon MP. So here option C is correct. These are standard formulas. Next question. The intrinsic or permanent electric dipole moment in the ground state of hydrogen atom is. Now for dipole moment, E is equal to minus of EE R cos theta. So if we take average value of this, then this will be EER cos theta. And now average value of cos theta, so this will be E is common, E common, average value of R into average value of cos theta, and that will be equal to 0. So intrinsic electric dipole moment of hydrogen atom, it will be 0 only. So option B is correct here. Next question. Which one of the following is allowed electric dipole transition? Now for electric dipole transition, delta L is equal to 0 plus minus 1, and it is going from 0 to 0. If it is going from 0 to 0, then it is not possible. Otherwise, we have 0 plus minus 1, and delta Z is 0 plus minus 1, and delta S is 0. Now we have to check for all. Here delta S is 0, so it cannot change. So it is S to S, this is P to D, D to P, and P to D. So which is allowed, that we have to find. So only option S is, we have to check for each. So this is S in the upper side. So this is 1 to 3, 2 to 2, 2 to 2, 2, 3 to 5. So this is not possible, this is not possible, because here S is changing. Here S is same. Then here we have 3 by 2 to 5 by 2. So delta J is plus 1. Here 5 by 2 to 1 by 2. So delta J is 2. So this is not possible. So B. In spectral term notation, this is 2S plus 1 LJ. So S should not change. So this should be same. And L can change by 1 and J can change by 1 or 0. Next, the term symbol for the electronic ground state of hydrogen atom is. Now for oxygen atom is. So it is 1s2, 2s2, 2p4. So we have p shell, p4. So this will be like this. 3 and 4. This is minus 1, 0, 1. Now we have to check S and L. Now for this, this will be plus half minus half. So this will cancel. So half and half. So this will be 2 into half, that is 1. And L will be minus 1 plus 1. So that is minus 1 only. So minus 1 and mod of it will be 1. So S is 1, L is 1. And J will be, because it is more than half filled, so that means J will be L plus S. So that is 2. And the term looks like this, 2S plus 1 L J. So S is 1. So 2 plus 1 is 3. J is 1. So P and L is 1. So P and J is 2. So this will be 3P2. So option D is correct. Next question. 4 mega-electron volt gamma rays emitted by the d excitation of 19F are attributed, assuming spherical symmetry, to the transitions of protons from 1d 3 by 2 state to 1b 5 by 2 state if the contribution of spin orbit term to the total energy is written as C into L dot S, the magnitude of C is. Now here it is given that we have two cases here, 1d 3 by 2 and 1d 5 by 2. Now for this we have L is equal to 2 because it is d orbital, and S will be half. And for the first case, J is equal to 3 by 2. So let us write J1 is 3 by 2 and J2 is 5 by 2. This is given to us. Now J is equal to L plus S. That means J square will be equal to L square plus S square plus 2 L dot S. So from here L dot S will be J square minus L square minus S square upon 2. So this will be equal to J plus 1 minus L plus 1 minus S plus 1 upon 2. Into we have H cut square. Now we have to calculate delta E. Now this delta E will be difference between these two. So this will be equal to that some constant, let's assume that constant is C. this is C, and into we have this separation. So that is value of L dot S for 5 by 2 minus value of L dot S for 3 by 2. So this will be equal to C into. Now L dot S, here J value is same for both and S value is also same for both. So we don't have to consider it because anyway it will be cancelled out, it will be subtracted. So we'll consider only this first part. So this h cut square by 2 is common, and then we have to consider j plus 1. So this will be 5 by 2 into 7 by 2 minus 3 by 2 into 5 by 2. So this will be c h cut square by 2, and this will be 35 minus 15 by 2. That is 20 by 4, or 4 will be there. That is 20 by 4, that is 5. So this will be equal to, and this is given that this is equal to 4 mega electron volt, because for the transition we are getting 4 mega electron volt gamma rays. So this energy difference will be energy of that photon. So this is C h cut square by 20 upon 8. So now we have this C into h cut square is equal to 8 into 4 by 20, which is equal to 32 by 20, which is equal to 1.6. So its value is 1.6, and here it is 4 is in mega electron volt, so this will be in mega electron volt only. So answer is 1.6, and answer given in the answer key is 1.6 to 1.6. Next question. An atom in its singlet state is subjected to magnetic field. The Zeeman splitting of its 650 nanometer spectral line is 0.03 nanometer. The magnitude of the field is dash Tesla. Now here we know change in frequency, it is EB by 4 pi m. And this can also be written as, since nu is equal to C by lambda, so that is delta of C by lambda, which is equal to, C is constant and derivative of 1 by lambda is 1 by lambda square. So this will be 1 upon lambda square into delta lambda. So from here B is equal to 4 pi m into, this C is also there. So this will be 4 pi m into C into delta lambda upon E into lambda square. I am equating this. From here I can write this. B is equal to. So now B is equal to 4 into pi is 3.142 into m, mass of electron. This is given 9.11 into 10 to the power minus 31 into value of C is 3 into 10 raised to 8 into delta lambda. It is given 0.03 and it is in nanometer. So into 10 to the power minus 9 upon E is 1.6 into 10 to the power minus 19 into lambda square. Lambda is given 650 into 10 to the power minus 9 the whole square. And this gives you B is equal to 1.52 Tesla. And answer given in the answer key is 1.51 to 1.53. So these were all the questions from GATE 2018 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.